This is my family's 1999 Chevrolet Tahoe, an American classic with timeless styling and a reliable, capable drivetrain. To many, this is the ultimate SUV, but right now, it looks like this. All of this mess is due to a speaker install that I should have done right the first time, 4 years ago. So in this video, I'm going to show you how I designed and 3D printed my own speaker adapter brackets with integrated water guards, a speaker crossover mounting plate to go inside the door panel, and while we're at it, replacing this blank factory switch panel with a custom designed one to hold 2 LED switches, a microphone for the stereo, and a USB input. Of course, we'll also throw the Chevy logo on the front too. Along the way, I'll show you how I reinstalled a proper vapor barrier and how I wired everything up. Thanks for watching my first YouTube video, and welcome to Josie Sound and Speed. So here's the scoop. About 4 years ago, I decided to install a touchscreen and upgrade the blown-out factory door speakers with a 6.5-inch Memphis component set and copious sound deadening. But in my way, I encountered a big plastic sheet glued to the door panel that definitely doesn't have an important job. Well, turns out that's called the vapor barrier, and it keeps water vapor from entering the cab and causing mold, and it also doubled as the water guard for the factory woofers. Depending on the state of the bottom exterior window seal, a lot of water can enter the door and fall right on top of the woofer, which is exactly what happened, and eventually the connection between the speaker terminals and wire oxidized to the point that they both stopped working completely. Also, I had poorly installed the woofers with sheet metal screws, and they've since come loose, so we need a good way to bolt the speaker to the door. So let's get into the CAD I did to fix this, as well as the fancy plate I made to replace the blank factory one. Okay, first we'll start with the crossover plate, which is going to be the easiest of the designs. We will sketch the dimensions and extrude the plate, and then add the holes for the square nuts and clearance holes for the bolts. Next, onto the speaker bracket with water guard. First, I made a rough model of the speaker itself, so I had a nice reference. Then I extruded the ring and made a sketch for the water guard, which I revolved 180 degrees. Next, I added the square holes for the square nuts that bolt the speaker to the bracket and made a clearance hole for the bolt. Then I added countersunk holes for the bolts that will attach the bracket to the door, and we're done. Finally, for the switch panel, first I measured the size of the panel and made a solid rectangle. It's usually best to apply the rounded corners or fillets last. Then I added this back section, which was also in my original part, and made a sketch for my tab. I dimensioned the total height of the tab, the thickness and size of the fillet, which changes how strong it is and also how flexible, and the depth and position of the retainer, which determines how much the tab needs to flex to insert into the pocket. I will say I had to print 4 or 5 prototypes to get the various dimensions of the tab perfect. Next, I used sweep to make one big tab, and then drew a sketch of where the tab shouldn't be and extruded it away. Finally, I sketched the holes for the 2 switches, USB, and microphone, and extruded them. Then I countersunk the face of the switches, and to do 3D printed inlays like this with a multi-material printer, I extrude down 3 layers, planning to print at a 0.2mm layer height, and then extrude back up as a new body. Finally, apply the fillets and chamfers, and there's our finished part. So I'll quickly go over how I exported and sliced the file. I colored the Chevy logo white in Fusion, and now I'm exporting it as an OBJ to Bamboo Studio, so the colors are already assigned. Next, I just need to place the face on the build plate and check my print settings. We want to make sure that we have enough perimeters that the tabs are printed solid, and also never use grid infill as it can cause print failures from collisions. And here, going layer by layer, you can see that we have some nice strength in the part, and the tabs are going to be printed totally solid. Also, you can see here that our inlay is only 3 layers deep, and therefore only requires 3 color changes. In PLA, the part only takes about an hour, but I would recommend using ASA so it will survive the UV exposure and extreme heat car interiors experience. Okay, so here's where the nice time lapse of the parts printing should be. Unfortunately, I did not record it, but I definitely will next time. So please enjoy the time lapse of this completely unrelated part, and let's go get to work.
Huh.